Hello again. I wanted to go back to my Fargate example. I got it to a state where, well, I didn't really know I was going to come up with these VPC issues that I did, and I quickly made a VPC template on the fly. There are two things I want to do in this video. One is to mess with that VPC template. Well, it does work, and there aren't really any problems with it. I want to make a few adjustments to it. Namely, I only have public subnets, and I would like to create private subnets as well. So I'd like to do that. And then the other problem, well, I wouldn't list it as a problem, but I left the video, the last Fargate video, and the only way I was seeing the Fargate service, and actually doing my API callback, was by enabling an auto IP. So on Fargate here, or not public IP, I assigned a public IP to the service itself, and that's how I get the service. What I would like to do in this video, and what I'm going to be messing with, is, like I said, first off, the VPC. I want, instead of just 4 subnets all being public, I want 2 public and 2 private. So C and D will become private. And then I want to go back to Fargate. Don't disable this assign public IP and route all the traffic through ALB. The ALB is defined actually in ECS yesterday. Yeah, and here. So I want this to be the way that I hit the Fargate service, and not directly. Probably better security anyway. Again, there's nothing wrong doing it the way that I did before. I don't think, depending on what your application is. But I just wanted to go back through and do this. I feel like it have a little more of a polished look. So I have been doing some reading. What I'm going to do is A and B are going to be public, C and D are going to be private. So I will probably be changing around the resource names a little bit. And hopefully I don't have to, mess with too many of the VPC settings and anything like that, but I do want to mess with it a little bit. So I think the availability zones, let me try to pull up some of the stuff that I've been looking at. This isn't exactly, I think it's like 57 here. Yeah, so these availability zones, they have public subnet and a private subnet in the same availability zone, and I would like to keep that. The more availability zones, the better. So this, and obviously I'm using huge subnets that you really wouldn't need. So just keep in mind that I am only going to be using 2 availability zones, reducing from the 4 that I originally had. That being said, it still follows AWS convention, so I don't think there's really that big of a problem with it. So this is more or less what I am going to work to achieve. I have an internet gateway in my VPC, and I have my public, so subnet A and subnet B both have routes and are associated with this route table, which gives me a route to the internet gateway. So we're good there. The next thing that I will need to do is to create 2 NAT gateways. Those each need elastic IP, and those within the public subnet as well. And then these private subnets will have their own route table, and the only route will be, well, other than their own route, they'll have a local route, and then they will have a 0.0.0.0, so 40/0, so just anything else, anything that isn't already routed, will be routed to their respective NAT gateways. And that's how the private subnets will be able to get to the NAT gateway. Then, so that'll be the VPC update. Then in Fargate, the Fargate service, right now, and it might only take 1, so I might only have it. Yeah, so this subnet, instead of it being in the public subnet, I'm going to transition this to the private subnet. And the ALB, this guy, his subnet, so this is correct. He will be in subnet A and subnet B in the two public subnets. Those will be his availability zones. So I have the CS cluster spun up. I'm going to delete this actually, and the reason for that is because I want to change the import value names. I don't want subnet A and B. I want public subnet A, public subnet B, private subnet A, private subnet B. So I will be changing these around. So I'll go ahead and start that. These to be public. And then these to be private. This will be A, this will be B, and I will change these to their respective availability zones. So that changes everything up to this point. I'm going to, before I forget, change the outputs to be reflective of the public and private nature of the subnets now. Lots of little naming updates. Naming is, it's got to be one of the hardest parts of all of this. Just making sure you have names that are unique but also make sense. It can be different. It can be difficult. That's why I choose to my CloudFormation. If I choose to write CloudFormation, choose the resource name if that's a possibility. For instance, well, the ECS cluster. I could have given it a name if I wanted to, but I like CloudFormation personally. And that's the reason why it's unique. I know it's unique. I know it will cause conflict. It's just nothing look better. So we have our route table. This is our public route table actually. Public default route is what we call that. Then we also need in your private route table, and again, all this work I'm going to make available to everyone using or through my GitHub repository. You don't have to follow along if you don't want to. This should all be in that repo. And if for some reason this ever changes, I would suggest looking at the video date of when I published it and finding a commit that is either on that page, depending on when I publish it, or around that date, and then you'll have, it's in source control, so you can go back there and look at the commits, and you can find exactly what I'm doing here, at least the results of exactly what I'm doing here. So, public subnet key route association. Get the public route table. That. Okay, now we have the private ones. And the private ones are, this is the new stuff for me. So I need to associate these to the private route table. also feel free to speed up the playback of this video. I understand some of the stuff might start to look a little repetitive. You know, I understand that. I won't be hurt, don't worry. Get some NAT gateways going. I believe NAT gateways need elastic IPs. Yeah. I'm just going to copy this block. I'm pretty sure this is more or less what I want, similar enough. I'm going to denote this. I'm going to move this private table down. So the public stuff is together, and we can keep all the private stuff together. So it appears I will need 2 NAT gateways, not just one. So I will do NAT A, and then I'll also have a NAT B. I don't want tag my subnet A, VIP. Don't know what that means. The route table must be okay. So on so the NAT gateway, the route table. This is the NAT gateway with a route table. The route table must be associated with an internet gateway so that the NAT gateway can connect to the internet. So if that's not necessarily in here, I might go rogue. This might not work, and I might have to redo some stuff. But I'm going to put the NAT gateway in the correct subnet. I bet the subnet this is the route, not the route table. So the route connects to a route table in the public subnet. And this is what? No, that doesn't make sense. I'm not sure. We're gonna have to figure it out. EIPA, B, then I'll need we'll call it NAT route. So the public default route. Those. Let's go ahead and take some dividers. Go out to 80 here. And then target subnet. And here we have public subnet. All of this. I'm going to redo these. So EIP, this is EIP. I don't usually use this format. I use this format to get at. See if I get a little more condensed. And this private route table is what the NAT routes fit into. Then the NAT themselves. The NAT should be in the public subnet, not the private subnet. Right, and then yeah, okay. I think I think that makes sense. If I straighten this out, so then it does. And then forward. Okay. Maybe. Switches. Yeah, delay speed there. Yeah, delay speed there. Okay. So I think what will happen is anything in the private subnet will have a route to this NAT gateway, and this NAT gateway, this NAT gateway is in the public subnet, which then has a route to the internet. I think that would work. We'll find out. So since I've changed these names around, I'm going to quickly look for instances of this, and I don't need to change it. This is just for my own kind of accounting. So I have a couple. I have a couple different locations with these things in them, these references in them. So I don't want to be too long. So I'm going to fix that. Okay. I'll go back. I'll have to change the Fargate template later anyway. Fargate template should be good. ECS clusters. They should have references. There they are. This thing get the public. Okay. So ALB should be in the public subnet. Actually, let's stop right there and see if the VPC template will work for us. This is something new. This is getting ready. Okay. Oops, get that with the wrong reference. Referencing a normal EIP and then EIP. There we go. Resolve. No. That thing. And that piece. Okay. VPC gateway attack. Yes. Don't know what that is. Can you see it? Okay, maybe it's that. Let me do that and say, because of a VPC gateway attachment, I bet it's referencing that. Yeah, I bet it means it exactly what I have. Brand new. Let's update it. Maybe that is it. Okay, it's referencing. See if we can find anything. I don't know. I don't know. What it's referencing. Oh, we got an error. Pretty much what we expected. Oh, because I changed it. I've seen this before. I'm gonna start deleting this and then I'll explain what happened. So there won't be errors deleting after that. So what happened was the CIDR, it says the CIDR already exists. It acts like it exists, and the reason for that is because the VPC template, originally the logical ID name was subnet A, subnet B, subnet C, subnet D. And they all had those cited. Cloud formation, I don't know why, but it doesn't wait for the existing resources well, actually, I kind of know why, but it doesn't wait for the existing resources to delete before it creates a new one. It keeps the copies up just in case it has to roll back, and it already has those resources existing. It's kind of like it leaves the existing, creates the new one. As long as the new ones look like they're working, it deletes the old one. Kind of like a blue green within a confirmation change set. So what happened was subnet A hadn't been deleted, and subnet A had this CIDR. So when I tried to create public subnet A, those CIDRs overlap and wouldn't let me create it. So that's what happened. Just you know, just unfortunate, but we're gonna take another whack at it. So a quick delete. So, now we'll recreate it. Since those sliders are now freed up, the subnets can take whatever slider they want because everything's open except the default ones. So now we wait for the VPC resources to spin up, and I'm gonna pause the recording and I'll do, well, I'm not gonna put it in here, so maybe not. Got route set up, we've got subnet set up. I'm guessing after the subnets get set up, then the NAT gateways will start to get set up. You know, get EIP, cool. Mentioned EIP a little bit. The pricing on those I think is really weird. It's like if you are actively using the IP address, it's attached to something and it's up, then it's free. But if you own the IP or you have it allocated, but it's not actively in use, then they charge you for it. I don't know. It's a little strange. Yeah, it doesn't incur charges as long as what it's associated with is running, and the instance only has one IP address associated to it. Otherwise, you're charged by the hour for elastic IP. Yeah, so I think what they're trying to discourage is people just hoarding IP addresses. They want them to be open and free so that everyone can use them. Which makes sense. I think that's fair. So it looks like all this stuff is going to get set up, which is awesome. That's what I wanted to see. So let's put a VPC and start poking around with the resources that have been created. So we know our VPC is there, our subnets are in there. Now I'm going to look at the route tables. So there should be 2 route tables, each with 2 subnets, 2 different subnets. One of them, so the NAT, this is the NAT one, and it only has the local because the NAT hasn't finished created. This is the public, sorry, that was the private. This is the public, you can see because it has a route for the internet gateway, so it will drain whatever else is not local to the internet, which is what we wanted to see. Now, setting up the route, and route identified by 0, 0, 0, 0, 0. Oh, and then it failed, so it's going to roll all the way back. Okay, so let's see. Oh, I bet I need 2 different route tables. I bet that's why. I bet I need a route table A and a route table B. Yeah, because if we're creating 2 routes, we can drain to different NATs. Yeah, I bet that was the problem though. This one, turned into A. Association also goes to their respective route tables. Okay. I bet, at least I hope, that'll fix the problem. While this is being loaded, which is fine, I don't know how it would be loaded. I'm going to go ahead and kick off this stack again and pause the recording, and I will be back once the stack is hopefully created. It took a little bit. Alright, the stack did work. I'm going to go to the last paper real quick and make sure everything looks right. So this is the public one. We've got the internet gateway, and then we have the two subnets, each pointing to their own NAT gateway. So the NAT gateway should live in the public subnet. So they're their EIPs, they're the private IP. So anything would hit this IP address and be forwarded onto wherever the traffic originated from. So the NAT gateway, anything on the internet cannot reach inside, but what is inside can reach out, if that makes sense. And we'll see, hopefully, the idea is that the load balancer will offer another path in, just indirectly to talking with the Fargate instance. So I'm going to, we'll see if this works now that I changed the subnets and stuff around, but I'm going to start spinning up the ECS cluster. Let's make sure it has any subnets. Nope, there are no subnets in the ECS cluster. Just a BTP ID. So go ahead and create that guy. And then next will come the Fargate stuff. So Fargate stuff we'll have to change because I changed it right here. So I'm going to add, or change this, and I'm going to add subnet B, so we have a little bit more redundancy. There should be no enabled IP address, and it doesn't. No more IP address, or sorry, subnet on reference. So I'm going to start creating the stack, but we'll monitor ECS stack because obviously that needs to be done before this stack comes up. I need to go grab my URL. Sometimes those roles take a while. Alright, I'm going to pause the recording again until the ECS cluster stack is done, and then I'll start on the Fargate stack. So I did get the stack up. I will mention though that there were two things I had to change real quick. Nothing to do with the architecture, but I did have some misconfiguration. The NAT gateway here, I had the subnet ID referencing the public subnet A, so there was actually no NAT gateway in public subnet B, so I changed that real quick, and then also the Fargate instance was on the public subnet, but it needs to be in the private subnet. I was getting an error where Fargate couldn't pull the image from the ECR, I guess from ECR, from the ECR repository, so it was erroring out. But once I changed this to reference the private subnet, it started working again. I haven't tested yet the load balancing, and that's what I wanted to do real quick. So we can see, okay, so on the last video, every time that, I think it's just the base path we hit, let's check the source real quick. Anytime the base path is hit, we get this misspelled received request log. So I'm going to, I really hope this works because that would be awesome. I am going to hit this load balancer and see if we can get a response back. And this is on port 83. Curl. Doesn't look like it's going to work for us. Okay. We have to actually change CPP. But it doesn't look like it. That, see how it's set up. Listeners HTTP on port 8080 network forward. It is the DNS name. But I don't really feel like there's anything wrong with that. But for some reason it's hard to prove things are set up correctly. It's the correct IP address. Okay. Well, obviously not seeing anything. That was supposed to be. That was supposed to get it there. But obviously not working. All supposed to be 8080 all the way through. Interested about this URL. So it does actually route. The address is a 10 dot, which is weird. I don't think this is weird. It's private IP, I think. I don't know how it. I don't know how to make that record. Sorry. Maybe it's because it's 88. Maybe I don't have security group set up for that. I have security group set up. No, it's 88. That is two. Oh, there we go. There we go. Well, I have them all set up. Can't resolve the IP address. System. I think there's some sort of security group on the load balancer. I'm going to poke around on all the recordings, but I'll be right back. Alright, I'm back, and I have my first success message I'm going to go through. Again, I did find out the issue, so you can see, I'll take the dash B off, you get the hello world back, so that's awesome, that's super exciting. The reason this URL was different is because I had to remake the ALB. I noticed, I was looking through and trying to debug this, I noticed the scheme was internal. If you go back to the very first video, I was looking through this and I saw internal, and I just, for whatever reason, I decided to go with internal scheme. But looking through this, I'll go ahead and read what the scheme is. The nodes of an internet-facing load balancer have public IP addresses. The DNS name of an internet-facing load balancer is publicly resolvable to the public IP addresses of the node. Therefore, internet-facing load balancers can route requests from clients over the internet. Sounds like what I wanted. But what I had configured was the nodes of an internal load balancer have only private IP addresses. The DNS name of an internal load balancer is publicly resolvable to the private IP addresses of the node. Therefore, internal load balancers can route requests only from clients with access to the VPC for the load balancer. The default is internet-facing load balancer. So I had it set up more or less that only clients with access to the VPC could route. So you would have had to more or less be an EC2 instance in my VPC in order to get the ALB that I had configured previously. But I reconfigured it to be internet facing. The reason why that URL is different is because the update required replacement, so I had to replace the entire ALB and spin the stack back up. So if you look, here's my task, my Hello World Fargate stack tab, and it routes, again, from the ALB, it routes port 8080 to this target group, and this target group is set to route to this IP address. I changed the ECS console, that's why it looks a little different. And if you look at our networking, this is the 10.0.2.91, 10.0.2.91, port 8080, and USC 28. So, I am happy to announce that I completed exactly what I was going for originally with that first video. I was able to get a container up and deal with it, but I wasn't really happy with the result. I wanted it to go through a load balancer and be a private subnet. So this is the continuation of that first Fargate video. I'll change the title accordingly, but now the VPC, I'll re-upload all of this to my, well, in case people don't know or haven't done it before, I have a GitHub repository called AWS Confirmation Reference, and I plan on continuing to post and update templates based off of stuff like this. Just it's not meant to be one size fits all. It's only meant to be a starting block. So I will upload all of this new stuff, the VPC changes and any changes I made to the Fargate templates. But feel more than welcome to reference them. They're out there. They're open source. I want people to use them, and please send me feedback if you'd like. My website is also thomasstep.dev. If you scroll down to the very bottom or on any of the, for instance, well, that's an old blog, any of the blog posts, if you scroll down, you can subscribe. To my mailing list, it sends out emails, or at least it should send out emails whenever I make blog posts. That's a new thing, so I like to see some people subscribe to that and hopefully get some updates and notifications. But thank you for bearing with me and stepping through how to build and debug this kind of thing. So VPC stack with a public and private subnet, all the routes set up from scratch, then an ECS cluster with an ALB in it. It's all import and export. I like to use imports and exports for confirmation. And then lastly, just a very simple hello world example using Fargate. Fargate it's all set up in the private subnet, and then the ALB is in the public subnet. And as we can see from this kernel, we can hit our API. So I'm very excited for that. So thanks for watching, and I'll see you in the next video. Bye.